All right, today we're looking at 8.5, alternate series test. This one's going to go quick. This is a nice, easy one. What is alternating series? The alternating series looks like a regular series, except for it's going to have a -1 raised to a power, and that power is going to make it alternate. So it's going to be -1 plus 1, -1 plus 1. An example would be like alternating from 1 to infinity, -1 to the n, 1 over n. So that would be, if n is +1, then we'd have -1 to the first power over 1 over 1. n is +2, -1 squared, 1 over 2. -1, 3, 1 over 3. And the reason this alternates is anything to the odd power is going to be negative, anything to the even power is going to be positive, and so forth, like that. So it doesn't alternate. Well, the reason I said this is going to be actually easier is this is how you can tell if the alternating series converges. It converges if and only if, 1, the limit as n approaches infinity of a sub n equals 0. So we've already talked about how to tell if a series converges, that this chance of alternating, but for a chance of converging. But with the alternate one, the one that's oscillating back and forth, that if this is going to 0, it is going to be convergent. So it's not even just have a chance. If you can just find the limit of that sequence series and see that it's going to 0, then you know it converges. But there is one other factor that has to happen, and that has to mean that a sub n plus 1 is less than or equal to a sub n. What does it mean? It means that each term, the absolute value of each term, has to be getting smaller and smaller. So obviously if it's getting larger and larger, it's not going to converge. So each term has to be a decreasing series basically, but it has to alternate. As always, it's probably best to just go ahead and look at an example. So if we want to see it -1 to the n plus 1 over 1 over n, very similar to the one we were just doing, anything raised to the n plus n of anything is going to alternate, because this is going to be, when n is odd, this is going to be an even number. For instance, 5 plus 1 is 6, 9 plus 1 is 10, and when n is even, it's going to be an odd number. So it's going to alternate. So I'm really just concerned with what this is doing. Well, this thing tells me two things. First of all, the limit as n approaches infinity, 1 over n needs to be 0 for this to be true. And clearly, you know that is 0. Bobo-Bot needs DC. Whatever it takes, it's 1 over infinity, which is 0. So the first part of alternating series is true. The second part is that the 1 over n plus 1 has to be less than 1 over n. That the next term has to be less than the previous term. Well, clearly this is true as well, because if I'm adding 1 to a number, I'm dividing by a bigger number, and that's always going to be smaller. So both of these are true, so it's easy to say that this indeed converges. All right, let's look at another example. Maybe it's not as easy to see that this is alternating. Now it's -2 to the n minus 1. I'm going to do this a little different than the book approaches it, but the end result is the same. I'm going to rewrite this as n over 2 to the n minus 1. And I'm going to pull out that -1 and also make it alternate n minus 1. So this is the same value as that bottom there. I just took it as two different ones. Now, -1 to the n minus 1 can be rewritten on top as -1 to the n minus, or to the negative n minus 1. I'm just moving it to the top. And then multiply it by n over 2 to the n minus 1. Cleaning this up a little bit, that's the summation as n goes from 1 to infinity. This, if I distribute that through, is 1 minus n, so -1 to the 1 minus n times n over 2 to the n minus 1. All right, so now, after just a little bit of work, we have that alternating there. So now I got to look at the other part. So as n goes from 1 to infinity, we have the alternating part, negative 1 to the 1 minus n. Yes, that does alternate there. Then my a sub n is n over 2 to the n minus 1. And I need to show that it, too, is going to go to 0. So the limit as n approaches infinity, this is the first part of the alternating series, of n over 2 to the n minus 1. Well, clearly, the bottom is exponential. And as n gets larger and larger, that's going to be way larger than the top, but it's just linear. So we're going to have a smaller number over a really large number. And when that happens, this is going to 0. So it's looking good for convergence. Maybe I just need to confirm the second part is that it is getting smaller each time. Well, so I need to prove that n plus 1 over 2 to the n is actually less than, I just added 1 to each n there, n over 2 to the n minus 1. And it makes sense that it would be. Even though I'm multiplying on top by a larger number, it's only 1 larger, but on bottom, this is a whole factor of 2 larger. That this is the equivalent of 2 to the 2 to the negative 1. Let me write it that way. 2 to the negative 1 times 2 to the n. I just broke this one up. So we can see that every time we're dividing by 1/2, we're dividing by 1/2, which is same as multiplying by 2, so 2 to the n, 2 times n over 2 to the n. Now, n plus 1, then we're really just comparing n plus 1 to 2 to the n, because everything else is equal there. So indeed, 2n is bigger than n plus 1. So it meets both of them, so we can now go back to our original saying and say, I'm confident that does indeed converge. All right, that's it for alternating series. I'll be back around to see if you guys need help.